We are going to discuss the second problem of the 2011 International Mathematics Olympiad competition, the windmill problem. It is interesting but also deceptively difficult. We have several points in the plane. None three of them are collinear. A windmill is a process that starts with a line going through a single point. The line rotates counterclockwise about the pivot until the first time the line meets another point. This point takes forward as the new pivot, and the line now rotates counterclockwise about the new point until it next meets another point. This process continues indefinitely. Prove that no matter how we arrange the points, we can always choose a point and a line going through the point such that the resulting windmill will use every point as the pivot infinitely many times. There were 563 contestants attending the competition. They are the smartest students from more than 100 countries. Only 22 of them completely solved the problem. In comparison, 51 students solved the third problem. It was a two-day competition with 3 problems each day. Traditionally, the first problems of each day are easy relatively. As a matter of fact, they are not easy at all. The second problems are supposed to be medium, and the third one are difficult. Apparently, in 2011, the organizers underestimated the difficult level of the second problem. Indeed, the solution is so easy to understand, but how to find the solution is a completely different story. The rotating line separates the plane into two sides, the red side and the green side. Whenever the pivot changes from one point to another, after the change, the old one is released to the same side as the new one was before. Therefore, the number of points on each side remain the same throughout the whole process. For example, in this picture, the green side always contains 3 points, except the transition moment when there are 2 points on the line. This is the key observation. Now, we can solve the problem by a simple casework. First, assume the number of points is an odd number 2n plus 1. We can always choose a point and a line through the point so that there are n points on each side of the line. After rotating 180 degrees, there should be n points on each side remaining the same, according to the observation we just had. Then the line must pass through exactly the same point at the end of the 180-degree rotation. In this picture, it is the point D. In other words, all other points switched sides during the time, either from red to green or from green to red. So, they must be the pivot point sometime during this 180-degree rotation. Case 2, 2n point, an even number. Choose a point and a line with n minus 1 point on one side and n points on the other side. After rotating 180 degrees, the split remains the same. If there are n minus 1 point on the green side, at the end of the 180-degree rotation, another n minus 1 point on the green side. In other words, 2n-2 point switched side during the rotation from red to green or from green to red. The remaining 2 points adjust the pivot in the beginning and at the end. Easy enough? Thank you for watching the video. Please consider subscription of my channel. I appreciate your support.